Hey, hello guys, good evening and warm welcome to Cat Mojos once again. So let's continue our journey on foundation, that's Quant Foundation, and we are doing the numbers. We started off sometime in the last week and maybe we'll conclude with a couple more sessions on into this particular week, and we'll start off with the arithmetic post this. Yeah. So good evening and warm welcome to all of you. Warm welcome to all of you. Let's get started. Yes, so if you technically want to know what is the course structure on this, so we will do foundation for about a couple of months, followed by we will do the intermediate stage. The foundation is technically take you to about 80 plus percentile in CAT, in the sense, say if I know my basics from 10th standard up to 10th standard, or a part of elements from 11th and 12th standard, will certainly help me to go beyond 80%. Just knowing the concept, not even too much of application, right? On the other hand, at the intermediate level is more about working on the applications built around this particular concept, which might take about 3 months because that's an important phase of our learning. Yes, so therefore that will take us somewhere closer to 95 percentile, and if you are lucky, maybe 99 percentile as well. Then we will do the advanced stage of learning, which will move us towards 100 percentile. Right? That's how we have done 3 stages, and then we will come back and do a little bit of the quick revision. That reinforcement we will do in the last couple of months. That's a kind of a course structure for the 7 to 8 months from now. Right? Okay, so just to give an understanding as to how we go about this entire course. All right, yeah, warm welcome all of you. Warm welcome. Hey, good evening, Ashutosh. Good evening. Good evening. Okay, so here we are on this note. So let me quickly introduce myself. I'm Belvi Srinivas. I've been working in the test prep industry since 2007, about 14 years now, and I worked in various organizations in various capacities, as you can see on this particular deck. Yes, I did develop some good skill to train the students in the space of QA, DI, and LR during that interval of those 14 years or so. Yep, that's briefly about me. Yes, I'm a good counselor as well. So if you have any counseling needs, certain counseling needs, etc., you can always reach out to me, and I will certainly try and help you with your objective questions. Yeah, good evening, Akshay. Good evening, Samita. Good evening, guys. Good evening. Yeah. All right. So how do you reach out to me if you have any short needs, in the sense like with respect to very short queries that you have, you can join these Telegram groups. Also, if you have any academic doubts, you can join this particular groups. Whatever the lectures I'm doing, if something is troubling, something you are not clear, a particular question, all right, now you could not follow, you can always join these Telegram groups and reach out to me. And there may be few peers as well. You can also have some peer interaction out there. All right, that's pretty much about what I want to convey on the introduction side. Yeah, there's another way to get resolved with your doubts, in the sense, even in my lecture, if you get some doubts or you generally get any doubts with respect to QA, DI, LR, and Wobble, you can make use of Ask a Doubt feature. That's another way that you find it on your Unacademy app. Please use that feature. You can ask up to 3 doubts in one single go. You can ask them, and one of them will come out either with a written solution or with a video solution. So whichever way it is convenient. If it is a very intricate problem, video solution. If it's a simple one, probably they might come out with a written solution, and so on. Right? So this is one feature that you can make use of. And you can also choose a language. Some of you, if you are not comfortable in one particular language, if you want that address to be in some other language, even that feature is kind of available there. And anybody taken CAT 21 test, in case if you have taken CAT 21 test, you can register for MBA Champions. Based on your score, you will get 10 times of your subscription fee back. Whatever, if you have brought some subscription, you will get 10 times of it back, up to 10 times of it back. All right, that sets us further. That brings us to the closure of the announcements. So in one of the lectures, I was just giving a little bit of background about the LCM and the HCF. So what we do here is, in the high schools, you learn 3 important models on LCM, and you learn 2 important models on HCF. Right? We will try and take a look if we can cover all 5 models today, or should we do only 3 LCM models and then take up the HCF models in some other lecture. We'll try and see. But yes, this is from the high school, which you should know. 3 LCM models, if you're already able to recall, it is good. Otherwise, I'll give a background. Hey, where am I going to use them? Two ways. One, there will be some direct questions sometimes, which would be easier, right? That would be easier. Second one would be sometimes the application question. In remainders you will find this, we call that as the Chinese remainder theorem. Now you may suddenly wonder, where is this Chinese remainder theorem coming from? Don't worry about it. When I deal with it at the intermediate stage, you will understand it. We use this as a part of the Chinese remainder theorem, right? Yeah. Rajput, you are trying to say that you want Unacademy number. No, I don't have the Unacademy number. I don't think Unacademy has a contact number. You can only navigate and use through the apps, etc. They might have an email ID, etc. Please check. There is no number. As far as I understand, there is no number. Okay, there is no number to interact with, which means there is no call center where you can call up and interact. I'm not sure, right? So as far as I know, I'm not sure if there is anything which has come up like this. I will find out and tell you in the next lecture. Is that fine? Yeah, let me find out, because this is the new kind of query even I encountered. So far, nobody ever asked me that give me a contact number of Unacademy. So let me also find out for you if there is anything like that, right? So because I'm not aware at this point. Fair enough. Okay, so back to the lecture. LCM model. Say there are three names. There are three names that we give to the LCM model. Say what is that? Model 1. So your teachers might have given different names. Okay, your teachers might have given different names. Try and recall how you tried to remember. I will try and put it to perspective how I kind of remember. Right? There is a model 1. So you call the model 1 is constant remainder model. We call it as a constant remainder model. Then there is a model 2. The model 2, we call it, model 2 is nothing but constant negative remainder model. That's a model 2. Model 3 is different remainders. Model 3 is different remainders. Okay, this is how I remember. If your teachers have given much sweeter names than this, yeah, go ahead and remember in that particular fashion. As I speak along, you will understand what is that I'm trying to say out here. So let me just start a discussion, a little bit of understanding about, hey, what is this? What is this whole thing is about? So even before I get into any of these models, let me just give a brief insight into it. How does these models technically kind of work like, right? Let me give a kind of small insight into this. For example, let's say that, okay, so let me take let me take some random example, then come into these models. Say if I given, so what happens in these LCM models is there will be series of numbers. What is that? Series, not one number. It's an infinite series of numbers. There is infinite series of numbers. What is given to me is you would be given divisor. In all LCM models, divisor is given, a respective remainder is given. A divisor and remainder is given. What I can find out is, I can find out the smallest number n can take. What is this n? N is the number when divided by a divisor leaves some remainder, right? That is the n. So but this n has infinite values. This n takes infinite values. But what is the focus? The focus is to find the smallest value that n can take. That is the focus. Let's understand that is about this particular model. Fair enough. Let's come to this. Let the divisor, if the divisor, let me take an example. If the divisor is 6, let's say, when the divisor is 6, respective remainder is 1. There is a number, I don't know that number. When you divide by 6, it leaves a remainder 1. The same number when divided by 9, it leaves a remainder 4. Now the question is, okay, what can be the smallest value n can take? N can take many values. Many values means what? There is a first value that n can take, there is a second value that n can take, there is a third value that n can take. Like this, there are infinite values n can take, many values n can take. Let me find out what is the first value n can take. That is the smallest value that n can take. How do you do it? Assume that, okay, I have no idea how to go about it. No worries. So you would have taken this. Okay, the number should be of the form 6 times of a multiple 6a plus 1. That is the meaning here. Hey, division algorithm. The number when divided by 6 leaves 1 as the remainder. How should the number look like? You say that, hey, my number should be of the form 6a plus 1. It should be of the form 6 times of a multiple and remainder should be 1. Hey, what are those kind of numbers? Those kind of numbers are 7. 6 1 times 6 plus 1 7. 6 2 times 12 plus 1 13. Put a is equal to 6 3 times 18 plus 1, which becomes 19. 6 4 times 24 plus 1 25. So you may wonder, sir, should I be writing all this? No, you should not be writing. I'm just telling what do you mean by the number should be of the form 6a plus 1. Why 6a plus 1? When the number is divided by 6, the remainder is 1, implies that the number should be of the form 6 times of a quotient plus 1. The quotient, I'm writing it as a. Okay, so on I can write this. Okay, then you say that 31, then you say that 37, and so on. There is no end to this. I can keep writing this. Okay, similarly, the number n should be also be of the form this, because this was the condition one. There is another condition, the same number when divided by 9, 4 is the remainder. Then how that should look like? 9 times of x plus 1. X is nothing but the quotient, 9 times of x plus 1. How does that should look like? 9 1 time 9 plus 1. Oh, sorry, 4, right? Plus 4. 9a plus 4 here. Okay, 9 1 time 9 plus 4, 13. 9 2 times 18 plus 4, so that becomes 18 plus 4, 22. 9 3 times 27 plus 4, 31, and so on. And I can keep writing this. Now observe this carefully. Are there some common numbers between them? Yes, 13 is the common number, which means my first value is 13. Hey, is there another common number? Yeah, I got the second common number is 31 between them. So I got my second value as 31. So point is, I can write many numbers like this. If I keep continuing this series here and keep continuing this series here, there is no end to this. I can keep writing the numbers as many as I want. So this is what I mean by the LCM model. Okay, now you may wonder, where is LCM here, sir? Already you are saying that it's an LCM model. Where is this LCM? This is what you learned in the high school. You say that, hey, the family of numbers, the number should be of the form LCM of the divisors. First divisor and second divisor. If there are many more divisors, take the LCM of all those divisors plus the smallest number that you have formed. That smallest number I will call it as n1. The smallest number that you have formed. What is the smallest number? 13. This you should know. This 13 you should find out a pattern and you should figure out that that smallest number is 13. That you should form, and then starts the game. We will find out. Hey, is there a way to find out the smallest number like that? Yes, there is a way to find that also. We will come to that in a while. In a while we will come to it. But for now you should remember that the number should be of the form LCM of the divisors, sum k times plus n1. What is this n1? The smallest number that you make an effort to form. That is the smallest number that you form. Fair enough. So that is nothing but what? N is equal to, in my question, what is this? LCM of, what is the first divisor? 6. What is the other second divisor? 9. I don't have a third divisor, no problem. Plus n1. Do I know the value of the n1 here? Yeah, you already found out. The value of n1 is nothing but 13. Good. I will write it this here. So therefore n is equal to LCM of the number, that is 18k plus 13. Okay, now you found out that my n should be of the form, for this question, 18k plus 13. Put k is equal to 0, you get n1. You put n1. If you want n1, you write this as 18 into 0 plus 13, because you already know your n1, which is 13. Put k is equal to 0, you get your first output, which is nothing but 13. Put n is equal to, second value of n is nothing but, put k is equal to 1 and add 13 to this. Alright, that would become 31, which you got as the second value. If you want your third value, put 18 into 2, alright, which is 36 plus 13, alright, which becomes 49. Likewise, you can keep finding the values of this particular series. There is no end to this. There is no end to this. How the questions would be presented, we will come to that. Alright, how the questions would be presented, we'll come to that. Okay, Samita, you are asking that how 18, LCM of 6 and 9 is 18. Alright, LCM, that's where we are talking about the LCM model. How 18? Look at the gap. This gap is 18, right? This gap is also 18. So what is this 18? That is the question. The first common value was 13 here. The second common value was 31 here, which means the gap between the first common value and the second common value is 18. What is this 18? This 18 is the LCM of 6 and 9. That is the LCM of 6 and 9. Got it? Yeah, that is the LCM. That's the least common multiple between 6 and 9. Alright, yeah, that's about this. That is what you mean by the LCM model. Technically speaking, LCM model means you take the LCM bottom line. Let me quickly come to the bottom line. Bottom line that you learn from the high school is LCM model means you find the LCM of the divisors k times, and the onus is always on the smallest number that you kind of form. The smallest number, the onus lies on you to find out the smallest number. Good. Now let me come to the models. I've set the tone, I've set the basic background to what you mean by LCM of the divisors. Quickly, two things to summarize it here. Always the question is to find the values n can take. They may talk about the largest 2-digit number n can take, largest 3-digit number n can take, smallest 4-digit number n can take. That's how they put put the values for n, because they know that n can take infinite values. No point asking how many values n can take. Rather, they can ask that how many values n can take which are less than 1000. Like that, they can ask these kind of questions. Okay, so what is required here? Unknown will be the number. Unknown is the number. What is known to us here? The divisors and the respective remainders will be known to us. Now it comes into three patterns. Let me quickly tell you the three patterns. Model number one. What we talked about model number one? Model number one is constant remainder model. For example, if I tell you this, hey, when the number is divided by 4, 2 is the remainder. When the number is divided by 6, still 2 is the remainder. When the number is divided by 2, still 2 is the remainder. I have the divisors and the remainders. Now constant remainder, 2, 2, 2 in every single case. The moment you see this, hey, the value n, because there is no one single value n. N is a series, it's a number series. How do you define this number series? N is equal to LCM of divisors. That does not change. What are my divisors here? All here you will be saying just like D1, D2, D3, etc. LCM of the divisors plus the constant remainder. Let me call it as R. If there is a constant remainder, you are lucky. You don't have to bother too much. You don't have to find out what is the smallest such number. The smallest such number is that constant remainder itself, right? You can add the constant remainder there. In this case, in this particular question, n is nothing but LCM of 4, 6, 9. All right, plus the constant remainder in my case is 2. This 2 is the constant remainder. If you get a constant remainder, you are lucky to get that. You can quickly put that to perspective, right? Yeah. So therefore you say that this is 36 times of k. Of course there is a k because it's a series. Yeah, 36k plus 2. This is going to be the values that n can take. Therefore if you say that, hey, I want the first such number. First such number is 36 into 0 plus 2. The first number is 2 itself. Hey, I want the second such number. Second such number is 36 into 1 plus 2, which becomes 38. Likewise, you can find out as many numbers as you want. Okay, is it making sense? Is it making sense? Can somebody respond in the chat? Is it making sense what I'm trying to say? The first model is clear. Very simple. I'm just recalling what you've done in the high school. Yeah, you might have forgotten also. Don't worry. It's okay. It's okay to forget. But the point is, if you forget, you should remember sometime. Now it's required for our quantitative understanding. I'm hoping that it's kind of making sense, right? Is it making sense? Clearly making sense to everybody? Yeah. All right. That's about the model one. That's about the model one. Nice. All right. Cool. At least one response. Ashutosh is responding. Thank you. Okay. Model 2. Let's get on to the model 2. Let's get on to the model 2. What did we say in the model 2? Model 2 is constant negative remainder. Right? Constant negative remainder. What do we mean by constant negative remainder? For example, again, divisors and remainders should be given. Divisors and respective remainders would have been listed for us. So when you divide a number by 4, let's say that the remainder is 1. When you divide a number by 6, let's say the remainder is 3. When you divide the number by 9, let's say the remainder is 6. Remainder is 6. I got something like this. Now you say that, hey, remainders are looking different. 1 is the remainder, 3 is the remainder, 6 is the remainder. It kind of appears to be different. But however, find R dash from R. So even before you apply the third model, check whether it belongs to the second model. What does it mean? Find the negative remainder. If the positive remainder is 1, how do you find the negative remainder? Subtract the divisor. When you subtract the divisor, the negative remainder is minus 3. So okay, here, all right. So I hope you are following what I'm trying to say. The positive remainder given is 1. So subtract the divisor, you end up with the negative remainder. Similarly, subtract the divisor. Divisor is 6. Remainder was 3. Subtract the divisor, you end up with the negative remainder. Same here. Subtract the divisor from the positive remainder, you end up with the negative remainder. Now you realize that, hey, negative remainders are constant, right? So positive remainders were constant in my first case, all positive remainders were constant. In the second case, every negative remainder is constant. Good. So therefore you say that, hey, how do you form the series of numbers in this case? The series of numbers is LCM of the divisors. There can be more than 3 divisors also. I'm just taking 3 here, 3 or 2, whatever, right? So the LCM of the divisors, k times, plus of the constant negative remainder. I'm writing r dash, constant negative remainder. This time it is not the positive remainder which appeared constant, it's the negative remainder which is appearing constant. Good. So in this question, how do you apply this? You say that this time I'm going to write the LCM of 4, 6, 9 k times plus of minus 3. Technically minus 3, plus of minus 3 is nothing but minus 3. Thereby you say that, hey, this is 36k minus 3. That is how my general form of the number look like from here. Hey, what is my first value? My first value is 36 into 0, 36 into 0 minus 3 is equal to minus 3. No, all right, no. When they say n, they meant that it's a natural number, right? It's not minus 3, because why I'm saying this is, hey, earlier you did this, you said that, okay, first value I will get by putting is equal to 0, but it's not true here. Here I should not put 0, rather I should start by putting 1. 36 into 1 minus 3, all right, which results in 33. That is the smallest such number. Okay, second number, of course, same, 36 into 2 minus 3, all right, that is 72 this. Therefore, it would become 69, and so on and so on. You can keep forming it. In the sense, there is no standard rule saying that, hey, first value always takes a 0. Not like that. It depends on how you are looking at it. So basically, as long as already your answer is positive, I am fine. If the answer is negative, ensure that don't give negative value for the number. The number, when they say, they technically mean that they are natural numbers. Okay, that's about the second model. First model, positive remainders are constant. This is how the structure looks like. Second value, the negative remainders are constant. This is how the second structure look like. So, but then you may have to check once before you apply the third model, just in case are those negative remainders constant. Sometimes you may realize that the negative remainders are not constant, right? Negative remainders are not constant. Let's take a look then. In that case, how do I go about this particular question? What if the negative remainders are not constant? Then what do we do? For example, let's say, let me take a number like this, divisors and remainders. I'm applying the third model, model 3. What is model 3? Different remainders. Different remainders means neither positive remainders are constant nor negative remainders are constant. Say you divided a number by 4. You divided a number by 4 and you got 1 as the remainder. Then you divided the number by 5 and you got the remainder as 3. You got the remainder as 3. Now let's say that, hey, what if I make an r dash? What if I make a negative remainder? You subtract minus 4, you get it as minus 3. You subtract minus 5 and then you get, and you form a result, or you form a result of minus. Right? You form, let me put it like this, right? Let me put this as 2 itself. Let me put it as 2 itself. Let me take it little better number 7, and I'm writing the remainder as 4, just for illustration purpose, right? Because that was leading to another issue there, so that issue I'm just trying to avoid. Yeah, okay. What is the negative remainder here? Negative remainder means reduce the divisor, it becomes minus 3. Okay, what is, let me change this to 2. What is the negative remainder here? Subtract the divisor, it becomes minus 5. Done. So therefore, negative remainders are also not constant, positive remainders are also not same. So therefore, it leads to what? It leads to another model. It leads to another model called as the positive, or it leads to another model. So which is nothing but the third model. How do we go across the third model? Simple. Always write the largest number here. So write this as 7a plus 2. Don't go by the smaller one. So go by the largest divisor between 4 and 7. Figure out what is the largest divisor. I'm telling you how you can technically look at this. So take the largest divisor and form the number. Your number should be of the form 7a plus 2. Good. So out of this, then what you see on this particular number is subtract this one. 7a plus 2, you subtract this one. If I subtract this one, it should become divisible by 4. If you didn't understand, let me write it mathematical structure here. Your number can be written as, from the first row, listen to this carefully, from the first piece of information, your number can be written as 4a plus 1. The same number from the second information can also be written as 7x plus 2. So I am solving these two parts. I am solving these two parts. How do I solve? Take this one to the other side. Therefore, you say that 4a is equal to 7x plus 2 minus 1. So which technically become 7x plus 1. So that's what I technically wrote here. Instead of x, I wrote a here. 7a plus 2 minus 1. Technically speaking, look at this number. Write 7x. then all it subtract the sorry, add this particular number and subtract the other number. In other words, mathematically speaking, this is what technically I'm trying to do. Okay, so now this number, therefore you have 4a, which implies this what? A is what? A is a quotient, right? A is a quotient, therefore 7x plus 1 should be completely divisible by 4. So you come across the situation where 7x plus 1 should be divisible by 4. You may wonder, how should I try this now? You should try the values of x from the smallest value. Values of x you should try from the smallest value. In a sense, start from 0, go to 1, go to 2 and go to 3. Only 4 test cases. You may wonder why only 4 test cases? Because if your divisor is 4, you will have only 4 test cases. Out of 4 test cases, exactly one case will work. For example, if I have all it, let's say 7x plus 3, 7x plus 3 when divided by 5, right? So it should be divisible by 5 also. There will be 5 test cases for this x. What are the 5 test cases? It should be 0, 1, 2, 3 or 4. One of these test cases will definitely work, otherwise after this there is no solution. One of the test cases would definitely work. Same thing out here. Put it to perspective, one by one we'll put it to perspective. If I put 0, it will become 1 to be divisible by 4, not divisible. If I put 1, all it becomes 8 divided by 4. If you put 1 there, so 7, 1 times 7 plus 1, 8. 8 divided by 2, yes, all this is completely divisible. It leaves a quotient of 4. Therefore, you say that, okay, I got the 1 is the number that I should be plugging. Where I should be plugging this number? Plug this number in one of the equations that you know. Plug it here. What do you mean by plug it here? From here, the equation is 7x plus 2 and you got the value of x is nothing but 1. Plug it here, 7, 1 times 7 plus 2, therefore you are saying that 9. The smallest such number is 9. Simply put, okay, you might have understood this, no big deal. In the third model, to find the smallest such number, you might require a couple of seconds, a few seconds may be required. From here, now you find the number, you find the series of number, or a general form of the number is LCM of the divisors, that is D1, D2, in this case, LCM of the divisors k times, plus the smallest number that you have already formed. I am writing it as n1. In this case, you write this as number is nothing but LCM of, what are my divisors? My divisors are 4 and 7. 4 and 7. How many times? K times. Yeah, what is the smallest such number that I have already formed? 9. 9 is already the smallest such number. Therefore, if you want the first number, you already know the first number. If you want the second number, LCM of the numbers is nothing but 28k, or like 28k plus 9. This is the general form of the number. If you want the second number, put k is equal to 1 and then add 9 to this number, which becomes 37. That is the second number. The first number is 9, the second number is 37, and so on. Okay, so this has put all 3 models into perspective. What are the 3 models that we are talking about? We talked about the constant remainder model. We talked about the constant negative remainder model. Then we talked about the different remainders. What do we mean by different remainders? Neither positive is constant nor negative is constant. So that's what we mean by the different remainders. These 3 things is what you kind of learn in the high school, which you should remember. All right, these 3 things are important. The mega application of this, direct applications, we will see now. The mega applications of this comes in the form of a Chinese remainder theorem, which we will do in the intermediate stage of our learning, right? Because that we have allocated 3 months for intermediate stage of our learning. During that time, we will explore that. So that time I'm not going to tell you these models, right? That time I'm just going to tell you that, hey, look, there are 3 LCM models. This is because courtesy, this we will tell. The courtesy, we'll just mention that. We will not discuss that. We will only mention that because discussion has already happened in the foundation stage, right? Okay, so that sets us for the problems. Let's take a look at few problems which we can kind of think about. Let's look at a few problems out here. That sets the models to perspective, the LCM models. We will look at few problems. Think about this. Think about this. Think about this. First, at least figure out which model it is. Right, in your mind, quickly figure out which model it is for 20 seconds. Then we will do it together. Right, yeah, this is model 1. All right, this is model 1. You may say that, hey, model 1 I will call differently. In the way we discussed this we will call it as a model 1. So in the sense, if model 1 is constant remainder model, constant remainder. What is constant remainder? Same remainder 2 in each case. Say, what are my divisors? Divisors versus remainders, right? When the divisor is 12, the remainder is 2. When the divisor is 15, remainder is still 2. When the divisor is 20, remainder is still 2. When the divisor is 24, the remainder is 2. You don't have to write it. I'm just telling you that, hey, it's a constant remainder model. Therefore, you say that the required answer, your number will be of the form LCM of the divisors, that is 12, 15, 20 and 24k times plus 2. There is no one number, it's a number series. There are infinite series of numbers. Okay, let's find the LCM of these values. LCM of these values is nothing but 8 into 5, that is 40, 40 into 3, 120. Therefore, you say that 120k plus 2. Please take your time to find out your LCM, whichever methods that you know. There is no hard and fast rule to find it. You find out, all of you know how to find the LCM of the numbers. Find the LCM, it becomes 120, 120k plus 2. This is how my series looks like. But is the author interested in the first number, second number? I can write my first number. Hey, what is my first number? First such number is 120 into plus 0 plus 2, that is nothing but 2. Okay, what is my second number? I can write 120 into 1 plus 2, which becomes 122. What is that author is interested in? Let's come back to this. He says that, hey, find the largest 3-digit number, right? Largest 3-digit number, which when divided by this leaves the remainder as 2. So why I'm solving this is, sometimes in the exam you will not have the choices, you will have the box. If you typically look at CAT 21, alright, if you typically look at CAT 21, in CAT 21 paper, right, so you had 8 out of 22 questions as boxes, which means about 35% of the questions already had a box. It's very, very important. Therefore, we should have a complete clarity about the concept, because 35 of the questions having no choice, it may go to 40% next year. We have no idea about it, but 35 itself is significant. Let's be very clear that 35 itself is pretty significant. Therefore, ensure that that's about like 1 out of 3 questions. Technically, you are trying to say that more than 1 out of 3 questions is theta question, which implies that every question, learn to solve it without choices. Learn to solve it. You can always make use of a choice. Say, how do you make use of a choice here? Simple. Take this 12, divide by this and check whether it is giving 2 or not. Take this number, divide by this 12 and check whether it is giving 2 or not. Without knowing models, you could have done this particular question. Hey, should I know some model to do this? Of course not. But the moment there is no choice, you need to have some understanding about this particular model. With choice, the life is simple. All right, now given this particular choice, I can randomly pick, start by 12 and check that, hey, which fellow is giving 2, then go to 15 and check whether the same fellow is giving 2 or not. So I don't have to know any models out there, right? I don't have to know the models there. So, but the models are required. The understanding is required. The moment the same question, I remove the choices from here and ask that, tell me the largest 3-digit number. Now the model comes in the picture, right? That's from that perspective, you should know how to go about it. Yeah, good. Let's come back to the discussion. So how do I go about this particular question? Therefore, you would say that, hey, so you have to get a ballpark figure, in the sense your n is of the form 120k, your n is of the form 120k plus 2. In this case, okay, plus 2 is a very small number, ignore it for the time being. Multiple of 12, it's a 0 is also fine. It should be a multiple of 12, taking you somewhere closer to 1000. Right, taking closer to 1000. You understand that 12 5s are 12 6s are 12 7s are 12 8s are. When you start doing it, you realize that, okay, 120 into 8, all right, now 120 into 8 will take me to 960. If I do 120 into 9, it will take me to 1080. It is 1000. No, but I want a 3-digit number. So therefore, a ballpark figure from the tables, you understand that, okay, I have to suitably put the value of k as 8 plus 2. When I add, I will end up getting 962, which becomes my answer. Okay, this is a pretty simple question. Good. Vishaka tried to put that equation there in the chat. That's all right. Good. Okay. Ashutosh has put the response there. Good, nice, good, very good, wonderful, wonderful. Right? Yeah, that's about the first model. Always ensure that you start solving the quant without choices. Assume it is a box. How do you do it? Because already in the last year, more than 1 out of 3 questions had the box. If it increases to 40%, oh, then you had it. Already it becomes very difficult. We need to have that confidence. Okay, let's come to the next question. Let's take a look at this question. Okay, yeah. Reflect. First, figure out that which model it belongs to. Right? We discussed 3 models. First, find out which model does this particular question come under. Okay, you might have figured out by now, you might have figured out that okay, this comes under the model 2 because not model 1. So divisors and remainders. Divisors and remainders. When the divisor is 32, remainder is 12. When the divisor is 20, the remainder, sorry, when the divisor is 40, the remainder is 20. When the divisor is 56, the remainder is 36. Right? These are the remainders. So from here, I will check before I apply the third rule. I will check that, hey, is the negative remainder constant by any choice? Yes, subtract 32, you get the negative remainder as minus 20. Subtract divisor, what is the divisor? 40, you get the negative remainder as minus 20. Subtract the divisor, which is 56, you get the negative remainder as minus 20, right? Therefore, you are getting them as minus 20, minus 20, minus 20. The negative remainders are constant. Therefore, you are getting negative remainder constant. You say that my number should be of the form LCM of the divisors, that is 32, 40 and 56. LCM of the divisors minus, or that's plus of minus 20, nothing but minus 20. You could have directly written this as minus 20. There is no issue with that. Okay, what is the LCM of these particular numbers? You have 32 and 5 and you have yeah, okay, 56, you have 7, right? Okay, so therefore in the LCM you have 32 and 5 and 7. This is what you got to multiply this. That gives the LCM multiplying these numbers. So you say that okay, 32 into 5 is nothing but 640. 640 into 7, am I right? Yeah, this should be fine. Yeah, this should be fine. Yeah, so that 32 into 5, 32 into 32 into okay, yeah. So this is, yeah, what I'm doing here is 32 into 5, 320, half of this 160, 160 into 7. Yeah, 1120k. Okay, let me write it directly here. Therefore, your number is of the form 1120k minus 20. This is the number. Your number is of the form 1120k minus 20. Okay, so what is my first number? The first number is N1 is equal to 11201 time minus 20, which will become 1100, which is not my answer. That's not going to be my answer. What is my answer? I will find the second number. Why? Author said that why don't you tell me second smallest number? Okay, therefore the second smallest number is 1120 times of 2 minus 20, right? Which will become 2240 minus 20, which would be 2220, which will be my answer. All right, 2220 is going to be my answer. Pretty simple question. So direct questions will come like this, but in CAT it is very rare. I'm not talking this from the CAT perspective. Yeah, if you get, you are lucky. Alright, I'm not saying that you will not get them in the CAT, but yeah, directly if you are looking at SNAP or NMAT or CMAT kind of exams, this itself can qualify as a question. But why we are learning this at this point in time? We are learning this so that we can apply this in the Chinese remainder theorems, right? Some simple questions come on the Chinese remainder theorem. For that, I need this understanding. Without this, I'll be lost, right? If I don't learn this now, I'll be lost at that point in time. Yeah, what if a sitter direct question comes? Lucky. All right, then in that case, we'll be lucky to get this, right? Okay, let's get on to the model 3. All right, this question is on model 3. We did one on model 1. We did one practice on model 2. Let's come to the model 3. Pretty simple ones. Pretty simple ones. Take a look at this. Maybe take about 10-15 seconds and try to close this. Yeah, okay. So this is the third model, because you understand that hey, there is a divisor and there is a respective remainder. When the divisor is 9, the remainder is 3. What about the negative remainder? Minus 6. When the divisor is 15, the remainder is 6. What is the negative remainder? The negative remainder is minus 9. Neither the positive remainders are same nor the negative remainders are same. Therefore, it does not help me, right? Neither the positive are same nor the negatives are same. Therefore, you say that I may have to resort to the model that I have learned. First, you may have to find out what is the smallest such number. How do I find out the smallest such number? From here, you write the equation as your number should be of the form. From here, you say that my number should be of, or let me write it in front of this here itself. Right, my number should be of the form 15 times of x plus 6. Okay, at the same time, from here my number should be of the form 9 times of y plus 3. Okay, equate both of them because both are talking about the same number, and hence you say that your number should be 9y plus 3, which also should be equal to 15x plus 6. Right, now solve it so that you will get your smallest number there. So you say that, okay, so I am solving this particular piece of information. 9y is also equal to 15x plus 6 minus 3. I just took this to the other side, plus 3. Okay, from here you say that y should be of the form 15x plus 3 divided by 9. So now I said that there will be 9 testing cases. What are the 9 testing cases? 0, 1, 2, like this you can go up to 8. But the point is start from 0. 0, no, it will become 3 by 9. 3 is not divisible by 9. Put 1, so therefore it becomes 18 divided by 9. It works. Therefore you are trying to say that for the value of x is equal to 1, it works. For the value of x is equal to 1. What is the value it is? It is the value of what? It is the value of x. For the value of x is equal to 1, it works. Come back and substitute for x. 15 times of 1 plus 6, which is nothing but 21. You are trying to say that n1, the smallest such number is 21. What you are trying to say is 21 when divided by 9, remainder is 3. That is what you are trying to say, right? Same 21 when divided by 15, remainder is 6. That's a point you are trying to make. Good. So smallest number you found. What is the family of numbers? The number family is LCM of the divisors, that is 9 and 15, k times, plus the smallest number that you already found out, which is called 21. You say that a LCM is nothing but 45k plus 21. This is how your general form of the number looks like. But the point is, he wants the largest 3-digit number. Simply put, 45 10 times 450, 45 20 times 900. Very good. Just take a guess. All right, now just look at guesstimation. Just look at these particular numbers. 45 10 times. If the value of k is 10 times, it becomes 450. What if I make it 20 times 900? Can I make it another 1 time? Yeah. So if I make it 21 times, that is 45 into 21, because 45 into 20 is easy, 900. 45 into 21, 945. 45 into 22 becomes what? 45 into 20 would become 990. But the point is, you are supposed to be adding this 21 also to this. All right, 945 plus 21 works well for me. 990 plus 21 becomes a 3-digit number, does not work well for me. 945 plus 21, therefore you say that 966 is my answer. Alright, for this question you say that the largest 3-digit number is nothing but 966. Alright, which when divided by 9 leaves the remainder 3, which when divided by 15 leaves the remainder 6. Right? Okay, so I have put 3 things to the perspective here. 1, we looked at the model 1, that is the constant remainder. Then we looked at model 2, which is the constant negative remainder. We looked at the model 3, where neither the positive remainders are constant nor the negative remainders are constant. Get hang of these 3 things. I wish I would have done the LCM model also, because of the paucity of time, I'm leaving the LCM models. Maybe let me check. I'm leaving the LCM models for the next lecture. A couple of quick announcements before we kind of close it. There are certain new batches which are starting. One is on 1st January. That's Bell the Cat. That's a good day to start. 1st January, Bell the Cat. Some of the fantastic faculty are taking this particular batch. You can check out this Bell the Cat, right? And if you are preparing for GMAT 2022, there is another set of faculty members, including me. We are taking it for GMAT 2022, which is generally due in the month of February, right? So that's what we are trying to do there. And if you look at yesterday, the percentiler batch has started. How do you understand what they teach is, you might have to, everybody would have done a short video of 3 to 5 minutes. Go back to the 3 to 5 minutes videos done by every faculty member to figure out how exactly they want to teach this particular course, right? How exactly to teach this particular course. All right, yeah, this is about this. And if you want to take that subscription, you may have to go for 6 months, 12 months, 18 months, 24 months. Check what suits you, and there is a 10% discount on every subscription fee that you can see here. So whenever you use any of the educator code, including my code, which is Belvi 100, doesn't mean you get 100% discount, you still get 10% discount, right? Yeah, my suggestion has been, in case you are going for a subscription, please go for iconic subscription, because you get 1-to-1 interactions with the mentor of your choice, which is very important. This one-to-one, you set it up. How many one-to-ones here? 25 one-to-one. If you buy 6-month subscription, you will get 50 one-to-one. If you get 12-month subscription, in the sense, one-to-one per week. You can interact with the mentor personally, one-to-one, and which agenda is yours. What do you want to discuss? You want to get your prep calendar in place. You want to get your you want to get to know which books to read, whatever be that. You come with the agenda, how to score better in the mocks when the mock season starts, how to improve a profile, all those discussions. You set up the agenda for one-to-one and go ahead, discuss week after week without losing your motivation, without losing your focus and attention. You could do that right here also, right? These are the nomination, these are the subscription charges. On this as well, you get 10% discount whenever you use any of the educator code. Yeah, that's pretty much about today. So I will deal with the rest of it in the next lecture. And there is a scholarship that you can avail of. Those are written CAT 2021, and if you are planning to repeat CAT 22, right, you can avail the scholarship. There is a flat scholarship up to 30 CAT scholarship of 30%, right? 30% scholarship provided you score more than 80 percentile. That could be something encouraging. You can figure it out. Yeah, if your percentile is this and you are trying to repeat for CAT 22, you can avail this scholarship facility. Yeah, that puts us to perspective pretty much. And if you want to interact with me, you can always go back to your you can go back, you can use this Telegram channel, and you can use one of these Telegram channels and you can interact. Yeah, thanks for being here. Thank you so much. Alright, thank you. So if you have liked it, so press the like. Alright, you can click on the like and put your thumbs up, and you can put that like button there before you leave. And yes, you can press on the bell icon, and you can press on the subscription, so that whenever I start the lecture, you'll be immediately notified. That's pretty much about it. I will see you guys tomorrow. So tomorrow is tomorrow with the premier lecture for the next 2 days. Then I will see you in the next year with the live lectures. All right, so catch you again at 4 p.m. tomorrow evening. Bye till then. Stay blessed. God bless you. God bless you, and God. All right, guys. Thanks, Ashutosh, Samita, and Vishaka. Thank you. So I will see you guys tomorrow. Ashutosh, LRDI will start in the month of Feb.